Hi, students and friends, host and teacher Sayyid Ayazuddin Haider, and you are watching Learn and Teach by Sir Ayaz. So I was doing the past papers 0620 and I'm done till 42. This time I have selected 43 and it's of May-June 2023. So let's start the paper. Question number 1. Some symbol equations and word equations A to J are shown. In A, it's a neutralization reaction. In B, it's a precipitation reaction. In C, it's a substitution reaction. In D, it's an addition reaction. In E, it's a cracking reaction. In F, it involves displacement reaction. In G, it's incomplete combustion reaction. H is a formation of ester or esterification. I is the reaction between hydrogen and oxygen to produce water. And the last J, it's the reaction which involves the formation of glucose during the photosynthesis in plants. Use the equations to answer the questions that follow. Each question may be used once, more than once, or not at all. Give the letter A to J for the equation which represents A, photosynthesis. I have just mentioned that J is a reaction for photosynthesis. This is the reaction between carbon dioxide and water to produce glucose and liberate oxygen. So J will be the right answer for A. B, an addition reaction. If you look at all these reactions, one of the reaction involves the addition reaction. And addition reaction is common in alkenes. So we have alkene here in D, propene, propene plus bromine, and we are getting only one product after the addition of bromine to propene, that is 1,2-dibromopropane. So D will be the right answer for B. Number C, a precipitation reaction. Precipitation reaction involves the formation of insoluble solid in the solution. So in choice B, you can see it's a reaction between Cr3 plus and 3 moles of OH negative ion to produce solid precipitate of chromium 3 hydroxide. This is chromium 3 hydroxide. So all the hydroxides are soluble. We have few exceptions, that's group 1 and from group 2, especially the metals in group 2 below in the group. Fine. So B will be the right answer for number C. D, incomplete combustion reaction. Incomplete combustion reaction involves the reaction between organic compound and oxygen, which is also known as burning, and the product produced is carbon monoxide and water. You can clearly see in G that methane is reacted with oxygen and products are carbon monoxide and water. So G will be the right answer for number D. E, a displacement reaction. A displacement reaction involves the reaction between a highly reactive element with the compound of the less reactive element. So in F, you can see there's a reaction between chlorine and aqueous potassium bromide. Look at the position of chlorine and bromine. Here they are in group 7. In group 7, the trend is reactivity decreases down the group, which means the halogens at the top will be able to displace the halogens below them from their compounds. Here they are asking about chlorine and the compound of bromine. So definitely this will be the right answer for this F. Last one, F, a substitution reaction. A substitution reaction involves the displacement of one atom in organic compounds, and it is common in alkanes. So C is the example of this displacement reaction. You can see the reaction methane is reacted with chlorine and the product is chloromethane and hydrogen chloride, which means one of the hydrogen in methane is displaced by one of the chlorine atom to produce chloromethane and hydrogen chloride. So C will be the right answer for this part. Moving to next question. Number 2A. The symbols of the elements in period 3 of the periodic table are shown. Here we have symbols of period 3 elements. We have Na, sodium, Mg, magnesium, aluminium, Al, Si, silicon, P, phosphorus, S, sulfur, Cl, chlorine, Ar, argon. Here we have period 3. This is period 3. Starting from sodium and ending on argon. Use the symbols of the elements in period 3 to answer the questions that follow. Each symbol may be used once, more than once, or not at all. Give the symbol of the element that, number 1, is present in purified bauxite. Bauxite is the compound of aluminium. So aluminium must be present in purified bauxite. Al is the answer. Number 2, contains atoms with a full outer shell of electrons. So we have only one element in this period that has full outer shell of electron, that is argon. Ar is a symbol. Number 3 is used to kill microbes in water treatment. Chlorine is used to kill microbes or bacteria during water treatment. So Cl will be the answer for this question. Number 4, forms an amphoteric oxide. We have only one element that forms amphoteric oxide here, and it is aluminium. So Al will be the answer for this one. Number 5, forms an oxide which causes acid rain. So acid rain is produced when non-metal oxides are released in the air. It can be either oxides of phosphorus, sulfur, or chlorine. The main culprit or most of the gas which is produced in the environment and is responsible for the acid rain is oxides of sulfur. So you have S as the correct answer, but you can write Cl or P also, because if the oxides of chlorine or phosphorus is released in the environment, they will also cause acid rain, as these oxides are acidic. Number 6, has an oxidation number of -1 when it forms a compound with hydrogen. So it has an oxidation number of -1 when it forms a compound with hydrogen. So look at the position of all these. So we have only one element that will be in group 7, which has oxidation state of -1 when it forms a compound with hydrogen. The compound will be HCl. So automatically answer will be Cl for this part. Moving to next part, B. The relative atomic masses of elements can be calculated from the relative masses of isotopes and their percentage abundances. Number 1, identify the isotope to which all relative masses are compared. It's carbon 12. So you'll write carbon 12. Number 2, table 2.1 shows the relative masses and the percentage abundances of the two isotopes in a sample of magnesium. So we have relative mass of isotope 24, its percentage abundance is 85, and another isotope, it has relative mass of 26 and relative abundance is 15. Calculate the relative atomic mass of magnesium to 1 decimal place. So what we will do, we will multiply 24 by the percentage abundance, that is 85, plus 26 will be multiplied by its percentage abundance, which is 15 here, and this will be divided by 100. So 24 multiplied by 85 gives 2040 plus 26 multiplied by 15 and we'll get 390 divided by 100. So 2040 plus 390 divided by 100. The answer is 24.3. C. An ion contains 10 electrons, 13 protons, and 14 neutrons. Number 1, state the nucleon number of the ion. In order to get the nucleon number, you simply have to add up these two values, protons and neutrons. So 13 plus 14 gives 27. Number 2, identify the element that forms this ion. Look at the proton number. Proton number is 13. So where will we find this? Here it is. It must be aluminum. Proton number is 13 and it has formed ion with 10 electrons as it is a metal. So you'll write Al or aluminium. Question number 3. Magnesium forms ionic compounds. A. Magnesium reacts with fluorine to form the ionic compound magnesium fluoride. The electronic configurations of an atom of magnesium and an atom of fluorine are shown in figure 3.1. Here is magnesium atom and here is fluorine atom. Figure 3.1. Number 1, ions are formed by the transfer of electrons from magnesium atoms to fluorine atoms. Complete the dot and cross diagrams in figure 3.2 to show the electronic configurations of one magnesium ion and one fluoride ion. Show the charges on the ions. So first of all, you should know how many magnesium and fluorine atoms are involved during this transfer. We have magnesium and fluorine. Magnesium belongs to group 2. Here is magnesium. Group 2 carries +2 charge. Fluorine belongs to group 7. It carries -1 charge. So +2, -1. Ignoring the charges, these are subscripts. These subscripts will be exchanged. And the final formula will be MgF2, which means that there will be one magnesium atom involved during the formation of magnesium ion and 2 atoms of fluorine involved in the formation of fluoride ions. One magnesium atom will donate 2 of its valence electrons. What is the proton number of magnesium? It's 12. After losing 2 electrons, it must have 10 electrons left. So this is the electronic configuration of magnesium. 2, 8, 2. After losing 2 electrons, it will be left with 10 electrons. That is 2, 8. And it will acquire +2 charge. So I'm going to show the 8 electrons in its second shell. They have already shown 2 electrons in the first shell. So here we have second shell. 1, 2, 3, 4, 5, 6, 7, 8. And it has lost 2 electrons, so it will acquire +2 or 2 plus charge. What about fluorine? Each fluorine atom will be receiving 1 electrons. So here's fluorine. What is the proton number of fluorine? Here is fluorine. Proton number of fluorine is 9. Electronic configuration of fluorine is 2, 7. So after gaining 1 electron, it has 8 electrons now in the valence shell and it will acquire minus charge. So I'm going to show 8 electrons in its valence shell. 1 electron will be coming from magnesium atom. So here are the electrons of fluorine first. 1, 2, 3, 4, 5, 6, 7. And the 7th electron coming from magnesium atom. So it has gained 1 electron. So I have to place minus charge. Number 2, deduce the formula of magnesium fluoride. I have already done this on the left hand side. So you'll write MgF2. This will be the formula for magnesium fluoride. Number 2, when solid magnesium fluoride is dissolved in water, it forms a solution that conducts electricity. State one another change that can be made to solid magnesium fluoride to allow it to conduct electricity. It must be in the molten state. So you have to heat it or melt it or molten state. Heat it or melt it or in molten state. Moving to next part. B, silicon tetrachloride SiCl4 and silicon 4 oxide SiO2 are covalent compounds. Complete the dot and cross diagram in figure 3.3 to show the electronic configuration in a molecule of silicon tetrachloride. Show outer shell electrons only. You need to show only outer electrons. So first of all, I'm drawing the key on the right hand side. For carbon, I'm using dot. For silicon, I'm using cross. Sorry, we have chlorine, not carbon. So it must be chlorine. Dot. Silicon. Let's look at their position in the periodic table. Silicon belongs to group 4. So it must have 4 valence electrons. What about chlorine? Chlorine belongs to group 7. It means it must have 7 valence electrons. So silicon will be sharing 1 electrons from the 4 with each chlorine atom. So I will show 1 cross in each circle of chlorine. 1, 2, 3, 4. What about chlorine? There are 7 electrons in their valence shell. 1 electron will be involved in sharing with silicon atom. 1, 2, 3, 4, 5, 6, 7. This one 1, 2, 3, 4, 5, 6, 7. This one 1, 2, 3, 4, 5, 6, 7. This one 1, 2, 3, 4, 5, 6, 7. So this will be the final dot and cross diagram. C, the melting points of silicon tetrachloride and silicon 4 oxide are shown in table 3.1. So we have silicon tetrachloride and silicon 4 oxide. The melting point of silicon tetrachloride is minus 69 degrees centigrade, and silicon 4 oxide, it's 1710 degrees centigrade. Number 1, silicon tetrachloride has a low melting point because it has weak forces of attraction between particles. Name the type of particles that are held together by these weak forces of attractions. It's definitely molecules. So there are molecules in silicon tetrachloride that are held together by these weak forces of attraction. Number 2, explain in terms of structure and bonding why silicon 4 oxide has a high melting point. So it has a giant structure and strong covalent bond. So you write giant structure, strong covalent bond, or many covalent bonds. Strong or many covalent bonds. Question number 4. Hydrogen is produced by the reaction between zinc and dilute sulfuric acid H2SO4. ZnS plus H2SO4 aqueous gives ZnSO4 aqueous plus H2 gas. A student carries out an experiment using excess zinc and dilute sulfuric acid. The student measures the volume of hydrogen produced at regular time intervals using the apparatus shown in figure 4.1. Lumps of zinc are used. Here's the apparatus. These are the lumps of zinc, dilute sulfuric acid, and we have gas syringe in order to collect the gas. The rate of reaction decreases as the reaction progresses. The rate eventually becomes 0. 1. Explain why the rate of reaction decreases as the reaction progresses. So you can mention the concentration of the acid particles decreases or frequency of collision between particle decreases. Concentration of sulfuric acid particles decreases or frequency of collisions between particles decreases. Number 1, explain why the rate of reaction eventually becomes 0. So it's simply all the acid used up or has reacted. All the acid is used up or has reacted. B, the experiment is repeated using powdered zinc instead of lumps of zinc. All other conditions remain the same. Explain in terms of collision theory why the rate of reaction increases if powdered zinc is used. The powder form has greater surface area, the frequency of collisions between particles increases. Powdered form has greater surface area, the frequency of collisions between particles increases. Moving to next part, that's part C. The equation for the reaction is shown. ZnS plus H2SO4 aqueous gives ZnSO4 aqueous plus H2 gas. 25 centimeter cube of 2 mole per dm cube H2SO4 aqueous is added to excess zinc. Calculate the volume of H2 formed at room temperature and pressure RTP. The volume of 1 mole of any gas is 24 dm cube at RTP. Use the following steps. Calculate the number of moles of H2SO4 used. So we have a volume of H2SO4 given as well as the concentration. So you should know that 1 dm cube is equal to 1000 centimeter cube. So you write 1000 centimeter cube contains 2 moles. Therefore, 25 centimeter cube contains X moles. So X is equal to 2 multiplied by 25 divided by 1000. 2 multiplied by 25 divided by 1000. 0.05 moles. Deduce the number of moles of H2 produced. Look at the relation of moles of H2 and H2SO4. It's 1 by 1. So it must be 0.05 moles. Calculate the volume of H2 formed at RTP. Simply multiply number of moles by volume in dm cube at RTP. So you will have 0.05 multiplied by 24. 0.05 multiplied by 24 and we'll get 1.2 dm cube of hydrogen gas. D. Hydrogen can also be produced by the reaction of zinc with dilute hydrochloric acid. Number 1, write a symbol equation for this reaction. This will be the reaction equation, Zn plus HCl. What are the products? We will get hydrogen gas and zinc chloride. For the formula of zinc chloride, you should know the valency of zinc. Zinc has fixed valency, that is +2. What about chlorine? Chlorine belongs to group 7. Here it's in 7. So it must have -1. Ignore the charges. So these subscripts will be exchanged. And finally, you will get ZnCl2. Let's balance the equation. So I will place 2 before HCl. It's balanced now. Number 2, state the test for hydrogen gas. Test is lighted splint and we'll hear pops up squeaky sound or pops up. That's all for this video. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.